So in Turbodesign Volute, just like in TD1, we start by loading the input file that was exported from TD3. And we can see the machine type has automatically been set as incompressible fan. And if we proceed to the main dimensions, then these have already been pre-filled from the TD3 file. And if you wish to export a manufacturing ready shell IGS model of the volute, you can also enable the 3D shell export option here and specify the wall thickness. And also the cross-section type has been set to symmetric, and the shapes at the entry, duct and outlet have been set as trapezoid with rounded corners, which is commonly seen in these fans. And the outlet tube settings are also preset to match those in TD3. And here we have the option to choose the type of outlet, such as tangential or radial, and we can go with a tangential outlet in this case. And finally, the most important part is the boundary conditions at the inlet, which is the specification of the radial and tangential velocity components coming out from the impeller wheel exit into the volute. Now, you may want to use uniform values throughout the circumference from the TD3 report, or you can also use a velocity distribution based on a CFD solution, for example, by importing the radial and tangential velocity profiles like this. And this is especially important in Sirocco fans where the flow variation around the circumference is highly non-uniform, and it's crucial to the stage efficiency that the volute design is optimized for the wheel exit flow. So next we can run the calculation, which runs a 2D inverse design code to give us the optimum area variation for the given volute inlet velocity distribution. And then in the post tab, we have a 3D view of the volute that we generated. As well as some plots such as the velocity vectors, and the cross-section area variation along the circumference, which is clearly unique and non-linear. And finally, there are also some useful performance parameters of interest, such as the total pressure loss estimate and other geometry parameters as well. And once we have the volute design, it is possible to directly export a solid IGES model of the same for a CFD analysis with the impeller, or a shell IGS model with the specified wall thickness.